How we doing, algebra? Welcome to today's video, talking about some inequalities, getting us ready for what we'll be looking at most of this week. So inequalities are really just like an equation, but instead of an equal sign, it has one of these signs. Could be a greater than sign, give Pac-Man some lipstick there, or it could be, I'll change my color, and it could be a less than sign. But you always want to be reading that kind of. And then just below that we have a little more explicitly what it is. Greater than or equal to, less than or equal to. That's all important stuff right there. And then really it's just going to be, inequalities are just a true-false question. Is something true or is it false? So you really got to be able to read that first. So A here is 7 greater than 3? That would be true. Is 0 less than 10? Yeah, that's true. Is 9 greater than 12? No, it is not, so that's false. Is 4 less than, and here's my favorite part, or equal to, less than or equal to 4? Yeah, it is, so that's true. Is 2 greater than or equal to 7? No, it is not, so that's false. Is 3.5 less than or equal to 4.2? Yes, it is, true. And 256 greater than 312? Nope, false. And 1,978 less than 2,042? That is definitely, absolutely true. Okay, so that's all we're doing with inequalities, and we just really want to know if we're getting them right or wrong, and I just wanted to do this short page so you could see all your symbols here. Definitely have to know what all of those symbols mean. All right, and really what we're going to see more of in algebra is we're going to look at kind of these expressions, algebraic expressions. 3 times x minus 2 is greater than or equal to 2x plus 1, and we might have to determine if it's true or false for a given value, or we're going to have to find a bunch of values, a lot of values that make it true or false. So we'll just test a couple of these real quick. We're going to plug in, I'll do it in green over here, we're going to plug x equals 10 into that. And there's my setup. It works out to be 24 is greater than or equal to 21. Yep, that works. We could try x equals 5. Let's try that one. All right, if I plug in 5, I get 9 is greater than or equal to 11. That is not true, so that is false. Okay, so far we know that 10 worked and 5 did not. Let's try 1. Let's see if 1 works. If I set up and plug in for 1, I get negative 3 is greater than or equal to 3, so that is also false. So right now what I might want to start doing is kind of start to develop a little bit of an idea, start thinking about what numbers are working. So 10 worked, 10 is good. 5 and 1 are both false, do not work. So I might start thinking about maybe numbers that are bigger than 10. So I want you to try right now, try a number bigger than 10 and see if it also works in this inequality. And then lastly down here, we'll just take a look at these real quick. You can try even more complex inequality expressions like you have over here. Throw 1 in there. I'll just jump right to the most complicated one. I'm going to throw 5 into this whole inequality right here. So let me pause my video and set that up. Okay, there's my setup. Let's work it out now. 5 minus 5 is 0. 2 times 0 is 0. 0 plus 1 is 1 over 3. 1 over 3 is less than or equal to, well, 5 minus 2 is 3 over 9. 3 over 9 simplifies down to 1/3. Is 1/3 less than or equal to 1/3? Yeah, you betcha. And this is going to be true, okay, true when x equals 5. All right, and that's really all there is to the basics of inequality. So if you know your inequality signs, greater than or equal to, less than or equal to, you can read them okay and you can plug in. That's really all we have to do today. Good stuff. Thanks so much, and we'll talk to you later. Bye. So now this gets a little more complicated with inequalities because now we're going to actually look at can we solve inequalities and do they abide by the same properties? And I'll tell you just right now, yes they do. Okay, so same as equals. Okay, you know what, I'm going to say they're mostly the same as just regular equations. So let's just check it out. We'll go through 1a, b, c, d real quick. 4 is less than 8. Yeah, that's true. Okay, we know that to be true. Add 3 to both sides. We'd have 7 is less than 10. Still true. Subtract 4 from both sides. I'd have 0 is less than 4. Still true. Multiply both sides by 2 and I have 8 is less than 16. Still true. Divide by 2 and I'd get 2 is less than 4. Still true. All right, I can do all of those first four things. But if we come down to it here in exercise 2 and we multiply by something like negative 2, well, now I'll get negative 8 is less than negative 16. Now, is that true? Is negative 8 less than 16? Less than negative 16, excuse me. The answer there is no, it's not. This is now false, okay? It's false. Because even though negative 16 is the larger number, if you think about a number line, okay, here's 0, here's negative 8, here's negative 16. Negative 16 is further down in the negative direction, and negative 8 would actually be, this sign should really be, let's see if I can get it in here, should really be greater than. Okay, and we'll talk about that in a second. And same thing if I divide it by negative 2, the same sort of thing happens. I have negative 2 is less than negative 4. And that's just not true. So multiplying or dividing by a negative number, okay, a negative number makes it false. That always happens with inequalities. When you multiply or divide by a negative, if you have a true inequality, it's going to go to false. So we have to deal with that somehow. And the simplest way to deal with that is exactly what I just did in the first part, is to just flip that sign. And we'll talk more and more about that this week for sure. So if I had just flipped this to greater than, right, starting with a less than, flipping to a greater than, it would have kept it true. So that's kind of how we offset the multiplying or dividing by a negative. All right? So now let's go ahead, let's try to solve a couple of these basic linear inequalities. I'm going to take a look at number 4 first. Okay, you want to solve this just like you would solve an equation, so I'm going to add 3 over. Again, adding 3 to both sides, totally fine. I have 4x is greater than or equal to 8. I can now divide by 4. This 4 is a positive 4, so I don't have to do anything fancy to it, and I can just finish up with my inequality. X is greater than or equal to 2. That's it. Okay, greater than or equal to 2. And just so you know how many solutions there are for an inequality, there's infinite. There's infinitely many. There's the infinity sign. Okay, write 5 numbers that make the final solution true. Okay, well I need numbers that are greater than or equal to 2. So how about 3, 4, 5, 6, 7? There you go. There's my 5 numbers. All right. And if I wanted to graph this, x is greater than or equal to 2, you'd go to 2. Kind of make a circle. I'm sure you've done this before. It's or equal to, so we fill it in. Okay, filling it in. And it kind of serves as, this is one of my other favorite things about inequalities, it sort of serves as an arrow pointing in the direction we should go in. So we'll just shade in over on this side. Okay, and the word that used to describe this is solution set. Solution set. All right, we'll do the same thing with number 5 real quick, and we'll see what happens. Okay, there's my setup. I'm going to subtract 8. That's fine. No problem adding or subtracting. I get negative 2x is greater than 8. And here I'm going to divide by negative 2. Divide by negative 2. Oh, I just said it. Dividing by negative 2. When you divide by negative 2, yeah, you'll get x. 8 divided by negative 2 is still going to be negative 4. But because this was a greater than sign, and I divided by a negative number, I have to flip it and make it a less than sign. Okay? And there's my solution there. So x needs to be less than negative 4, so I'm going to circle negative 4. Okay, like that. It's not or equal to, so I'm going to leave it open, and I'm going to shade all in down here. Okay, and anything less than negative 4 will make that inequality true. So thanks very much for watching. That's a little intro for inequalities, and I will see you tomorrow. Have a great day.